All right, I thought this problem was kind of a drag, you know. All right, sorry. Uh, um, an athlete who's about to quit whatever it is, whatever sport they're training for, trains by dragging a heavy load across a rough horizontal surface. The athlete exerts a force of at a magnitude of F on the load at an angle of 25 degrees to the horizontal. Once the load is moving at a steady speed, the average horizontal frictional force acting on the load, so it's moving at a steady speed, right, um, um, is 470 newtons. Calculate the average value of F that will enable the load to move at a constant speed. So you've got, this is 470, right? There's some vertical component that doesn't do any work, and then here's F, right? And that's 25 degrees, right? You are going to use your trigonometry. I think I used, cosine or something like that, right? Use your trigonometry to find the hypotenuse, because that's going to be the force, right? Go for you. All right, then the load is moved a distance of 2.5 kilometers, so the distance is, S is 2,500 meters. The time is 1.2 times 60 minutes per hour, 60 seconds per minute, right? So you got to turn the time into seconds, right? Okay. Calculate the work done on the load by the force F. Okay. Well, remember, well, you can use Fs cos theta, right? Fs cos theta. I believe that would work, right? And you've got the distance, right? You've got the angle. But, you don't need to do that because they tell you the friction force is 470. That's the horizontal force. So you could just say Fs for the work, right? Find the minimum average power required to move the load. Well, power is just going to be the work divided by the time. Okay, power is work divided by time. So whatever answer you get here, you're going to divide by that time, right? And then the athlete pulls the load uphill at the same speed as in part A. Explain in terms of energy changes why the minimum average power. Well, if you're going uphill, in terms of energy changes, right, it seems to me that you are gaining potential energy. And since you are gaining potential energy and doing as much work, right, you're moving at the same speed, right, okay, but also gaining potential energy, your work is going to be more. It's going to be work, the ordinary amount of work plus whatever the potential energy is, right, divided by time. Okay, make that argument with words. Good enough?